Good day. This video will show the solution to the problem of the day posted. First problem of the day posted by MathSoc. The problem was uh, a segment having endpoints 0, 1, and 50 will be rotated about the origin at an angle of 120 degrees clockwise. And the question is, what would be the coordinates of the segment after the rotation? So when you do rotation, the endpoints of your given segment when connected to the origin. For example, this endpoint 0, 1 when connected to the origin you will create a smaller segment, this blue one here, and this is what we will rotate about the origin at the said angle 120 degrees clockwise. So let's do that. So when you rotate it, of course, this is now 90 degrees, so a bit over 90 there, so it's your 130. So now the endpoint of this little segment right here would be the new place for our endpoint. So to illustrate, this would be the endpoint of the new segment after the rotation. So doing the same in the other endpoint, the 50. So this is 5 units away from the origin. This segment right here, this larger blue segment here, and this will rotate about the origin 120 degrees. So let's do that. So you know, 50, it's 90 degrees now, so a bit over, it's 30. So the endpoint of this would be the endpoint of the new segment after the rotation. To illustrate, connecting this is our new segment after the rotation. Let's remove this now, and this. So what would be the coordinates of these two, the blue segment after rotating the red segment 120 degrees about the origin clockwise? So to do that, let's redraw the problem here in a larger scale. Okay, so you see that this right here is somewhere in the fourth quadrant, a bit close to the x-axis, a bit further from the y-axis. So let's just put it right here, and this one is a bit closer to the y-axis and then farther from the x-axis in that manner. So we have here, can make it look like this one. So remember, I'm just making it into scale. So remember that this this point here is still 1 unit away from the origin, and this point right here is still 5 units away from the origin. So remember that physical properties will not change because of rotation. So meaning, I'm connecting it using a red line now. This right here from the origin to this point is 1, and this to the other point is also still 5. So what do we have here? So we apply here your simple trigonometry. Remember, the rotation is 120, therefore this would be, this angle right here would be 30 degrees. And here you have your right triangle, 30. You know this is 1. So the opposite 30, you know this is 1. So opposite 30 degrees, this would be 1/2. And the length of this here would be square root 3/2. Of course, the coordinates of the point where in the fourth quadrant would be positive square root of 3/2 and negative 1/2. Negative because we are in the fourth quadrant for this point. Now for the other endpoint, this is 5. So again, if you will draw this, you again will have a right triangle here. What's the angle here? So remember, this red segment is rotated 120 degrees about the origin. It was a horizontal line before, and now it's here. So this must be 30 degrees, and this is 60 degrees. So if this is the hypotenuse now would be 5. This must be 30 degrees. Therefore, opposite this 30 degrees, this must be 5/2. And then the other the length of this segment must be 5 square root 3 over 2. Now, we know that the point is in the third quadrant, therefore, the coordinates are negative 5 halves and negative 5 square root of 3 over 2. These are the new coordinates of the new endpoints after the rotation. So the problem, I believe, was taken by Team Omega. So, good day.